Hey everybody, Mr. Simone here. The purpose of this video is to show you how to graph a linear function in the terms of point-slope form. Alright, when we look at point-slope form, or equations that look like they're in point-slope form, they're in this form. Okay, y minus y sub 1 equals m times the quantity of x minus x sub 1. Now where this actually comes from is from slope. Okay, which is m, which is your delta y over delta x, change in y over change in x. We know that we can write our change in y as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, that's where that is. Now where this is derived from is that slope formula. And one thing, if you notice, if I decide to take my slope formula and just kind of rearrange it a little bit, so instead of saying m equals, if I actually say that this is equal to m, I can multiply both sides of the formula here by what the denominator is, which is that x sub 2 minus x sub 1. Alright, if I multiply this side by that, I can also multiply this side by the quantity of x sub 2 minus x sub 1. And you'll notice that you have this y sub 2 minus y sub 1, your change in y, is equal to m multiplied by that quantity. So that's where that comes from. It's derived. It basically is decomposing your slope. Now, what x sub 1, y sub 1 is we call it a particular point. It's a point that is actually on the line, or actually on this, this line, and slope is used to find other points. That's why it's called point slope. So the goal for today is to show you how to actually graph using this. All right. These are just some notes that we've used from class, and we'll kind of go through on how we derive this. How does this all work? So just like slope-intercept, where you're given the slope and the y-intercept, point-slope form is a form that gives you not only the slope, but a specific point on the graph. And we're going to talk about how we can find both of those. So the first thing you want to do is you want to identify what your slope is, what your rate of change is. And when you look at an equation, we know slope is m, so we're going to look at our point slope form and notice that in the m position is this value of 2, which means that our slope is 2. And a lot of times you'll say to yourself, well, what does that mean? Well, your slope, a whole number of 2, means that your rise is up 2 and your run is 1. Remember, you can represent slope as a ratio of change in y over change in x. So it might be a good idea just to put your value of 2 over 1. The second thing we want to do is we're going to want to graph a particular point, which is your x sub 1, y sub 1, which basically gives you a value that zeroes out the equation. So we want to make a point that works that we know will zero out both sides of the equation. On my y side, the only value I can use for y to zero out is the value of 4. So using our particular point, we know that if we want to zero out the equation, meaning put your equation in balance, we know that y must be 4, because 4 minus 4 is 0. And at the same time, if I want to get my x value to zero out, the only x value I can have here is that x must be 3. So what does that mean? Well, it means that if I plug 3 in for x, I would get 0 for this quantity, and 2 times 0 is 0. And at the same time, if I plug 4 in, 4 minus 4 is also 0. Is it a true statement? It is. 0 does equal 0. So I have my particular point, 3, 4. We're going to graph that. So go over to 3, up to 4. There's my specific point that I know does work for this equation, which makes it true. And then, just like slope-intercept, I'm going to use the slope to plot other points. My slope of 2 over 1 means I'm going to go up 2 and over 1 from my particular point. So up 2 over 1. All right. What's not showing here is this idea of rise over run. We also know that your slope can go in the opposite direction. So instead of going up 2 and over 1, I can also go down 2 and to the left 1. As long as I keep that integrity and I have that rate of change, I can continue the pattern until I exhaust the graph. Once the graph is exhausted and all points are put in, I'm going to draw a line connecting everything together and an arrow. So this is the third form of our linear functions that we'll be looking at. We've looked at slope-intercept, we've looked at standard form. Remember, that standard form is that idea where the x and y intercepts are shown really easily. And point slope is just another form that is derived from the slope formula that allows us to see not only a particular point, but also your slope. We're going to look at a few other examples. Be mindful that you can freeze this video whenever you would like. All right, I'm going to look at my equation here. It is in point slope form. The first thing I want to do is figure out my slope. So our m is -3/4, which means I'm going down and to the right. My particular point, I usually put a little star just to mimic it, but I need to find my value that will zero out the equation. In other words, make my equation balanced where 0 equals 0. For x, the only x value that will work here is that my x value must be -3, because -3 plus 3 is 0. For my y value, what's the only y value that's going to make this quantity equal to 0? It is going to be +2. So there's your particular point. Particular point of -3, 2. I'm going to plot that. And then I'm going to use the slope to plot all my other points. From my particular point, I'm going to go down 3, 1, 2, 3, and over 4, 1, 2, 3, 4. Continue the pattern, down 3, 1, 2, 3, and over 4, 1, 2, 3, 4. If I try to go in the reverse direction, if I go up 3, 1, 2, 3, I need to go over 4, and I'm off the graph. So we have 3 points that are defined by this equation that will fit on the graph. To show that it continues infinitely in either direction, we do connect it and put arrows on the ends. For the last example, same idea. We have a slope. You're going to look at what that quantity in front of your parentheses is. It is 1/2. Change in y is 1, change in x is 2. So my vertical change is 1, my horizontal change is 2. They're both positive directions. Your particular point, you're trying to figure out how can I zero out this equation? How can I balance it so 0 equals 0? For my x value, you'll notice that it's x plus 5, so x must be -5. And for my y, I have y plus 1, so y must be -1. Again, -1 plus 1 is 0, and -5 plus 5 is also 0. So -5, -1, I'm going to plot my particular point. And just like we've done in the other examples, we're going to plot other points using the slope. Our slope is 1/2. So up 1 to the right 2, up 1 to the right 2. You're going to continue that pattern, that rate of change, to plot all the other points until you can't go in either direction. Once you've exhausted the graph, you connect everything together, and you do in fact have your line. Now, what's really nice about point slope form is that you can actually rearrange it and convert it into either standard form or slope intercept. So the next video you'll see, I will show you how you can also rewrite something in point slope form into slope intercept, which is another way, which is a comfortable way that we can also graph lines. But overall, this video, hopefully it helps you. Point slope form, why is it so special? Because you're given a particular point and you're given slope to graph all other points on that line, or that line that's created. All right, hope this helps.